I have some time. I'm going to show you what I'm working on now. Here's the schematic so far. Let's see, here would be your input. I'm working through the camera here. This would be your input from your solar panel. That's anywhere up to 20 volts, which would power this regulator here, which powers this comparator. This here is your photoresistor. Right here is the potentiometer for the sensitivity for the light, and that will trigger or activate this transistor here. This is the 139, I believe, and that will power your LED array. This transistor can handle a maximum of 1.5 amps, and I believe the original specification you told me was about 100 to 200 milliamps. So that's nearly an order of magnitude over your specifications. And I got some test points on here. And let's see, I'll show you what I haven't started working on the board yet. Here's what the board looks like now. It's just all thrown together, and this is what it would look like in real life. And it's going to look much different than this. I'm gonna crunch it down a little bit so I can, place the parts in a logical fashion anyway. And I'll be able to do that. Let's see. Yeah, so there's the potentiometer here. I know the glare. I'm getting a lot of glare here. Yeah, these are the two parts here that does all the work. This little guy here. This little guy here is going to do all the hard work for you. Let's see. I got the data sheets, and I'm going to have links for the data sheet here. You probably can't see all that, but that's the LT1716. So if you did a search for that on Google, it's from Linear Technology. You can get this data sheet, and you can see what it's doing. The whole thing should run under 100 milliamps, and I'm actually shooting for not 100 milliamps. I'm shooting for 1 to 200 microamps while it's on. I mean, when it's off. So during the day, it won't take a whole lot. That's the whole idea. And let's see. There's the transistor. That's the BD139. You can check that out as well. So that's where we are now. Put maybe 3 hours into it already. Not even. Most of the work, and I probably put maybe 4 or 5 days into just researching the components. For the just for doing that and going through what I have in stock and everything else. But yeah, long story short, I think we're done. Okay, I should have this done by midnight, fully tested and ready to go. I think the most difficult part with any project is the enclosure. Alright, we're looking at the PCB layout with all the footprints here. You can see I'm just starting to get placement for some of the major components. Right there, that's the voltage end coming from the battery, from the charging unit. Just getting things lined up. If you can't tell, this is a voiceover, so I'm not actually doing this as I'm working. And those are some test points there. It's good to have test points on your board whenever you're making a prototype or any type of board. You want to be able to measure your parts, measure your components and stuff for key locations on the board anyway. And I'm just setting up the location here for the filter, the main filtering caps for the regulator. They're small value capacitors because of the it's what I found that those regulators really like. They like these are actually this particular regulator is actually very stable with smaller value capacitors, so that's the way to do that. Yeah, filtering is important, even though it's coming from a battery. You still, it's just good practice to do it, and it doesn't cost that much more to have them slapped on the board. And just getting yeah, I'm just setting up positioning on the capacitors right, so that there's space in there to get everything on there. I'm going to be soldering these by hand, so I'm trying to keep that in mind. Because right there, those are pretty close together. So I'll probably be moving those. Yeah. Yeah, because you want to get your iron in there and stuff like that. There's our regulator. I typically don't connect the grounds until last because I typically use a ground plane. So that's the last connections I make when I'm making a board. That's our comparator there. Get all that lined up. Must be taking a break or looking at the schematic to see where everything is, because you pretty much want, what I've found is the easiest way to line up a board is to look at the schematic, how the schematic is laid out, and kind of manipulate the board to look to somewhat match the schematic. It doesn't always work out that way, but when you're drawing your schematic, you want to try to keep the lines, the traces as clean as possible, so that they're not overlapping, so that when you get to the board, it can almost be an exact, almost look just like the schematic in a sense. Yeah, that's your filtering cap for the output stage of that linear regulator. C1 and C3 are the input filter caps. C2 would be the output filter. And I'm just looking around. I think I'm playing around with the designators and the looks like the values for those components, just to clean things up, make it look nice. Moving things around and trying to keep everything nice in order, because I'm thinking I'm liking that, how this is looking out so far. What do we got next? Another test point for the output on the regulator there, the output regulator. Let's see if we can find a nice spot for that. Looks good. And I know I do a well, I don't want to get ahead of myself here, so yeah, it looks like I'm looking at the schematic again, looking for a particular part, and that's our photo resistor there, our LDR. footprint there. I don't know if you know what that looks like. That's a universal it's a universal footprint. So it has both through hole and surface mount, all the way from 0603 all the way to 1206, I think. So yeah, that can handle all of them. It's a universal footprint. It's kind of handy to have when you're doing prototypes. So that's a new footprint for KiCad, and I like it. Yeah, it was a good idea. That's our potentiometer for potentiometer for the for adjusting sensitivity to the device for the light sensor, and I think I'm just trying to see how I want everything going. See, I really don't pay attention to the grounds, because like I said, I don't really care about ground until it's all done. Typically get all the traces done, all the main traces first, and then just do a flood fill and just do a ground plane. Here it looks like I'm using the dimensioning tool to get some measurements here, and I want to take a horizontal measurement here. So I want to find the center of the board, or at least close to it. For 40, there we go. So that would be the dead center on that. Now we want to do the horizontal, or the vertical side. And I'm adjusting the grid so I can line up the line everything up there. Yeah, it looks like I was a little off skew there, and I'm going to end up having to do that over. I remember that part. Yeah, because when I bring it over, you'll see that now. You'll see that when I get to the other end of the board, how off it is. So yeah, I'm going to do that over. And looking for 15 on the nose. There we go. And there's the center of the board. So that's what I'm going to use to line up that potentiometer with. And done and done. I think what I'm going to do now is lock the footprint in place so it doesn't move. The menus don't pop up when I hit the right arrow key, or when I hit the left mouse button for whatever reason. Or the right mouse button. For some reason, it didn't record the menus. That's kind of disappointing, because I wanted you to be able to see the options that I was picking. So yeah, next time I'll do a better job of that and make sure that that's working properly. I'm just playing around with some footprints here, some of the test point. And I think what I'm trying to do now is line it up with the test point 9 there, just to make things look nice. See, I just want to have those like lined up, and I think it would be a better location for a test point anyway. You know, you want to be able to get your flying leads in there, so it's comfortable to do that on the board. And I'm taking another measurement here. It's 4.5 millimeters, and we're going to try to match that up. we're a little off, so we're going to move that up a little bit. And we went too far. There we go. Let's double check it. 4.5 it is. Done. And we're going to continue that. Over on that side. Yep, and that's out a little bit. Okay, so that's taken care of. We're getting there. We are getting there. Saving our work. The software does save it every 5 minutes, I believe, but hey, it's a good proof of concept to just to do that, just to be in the habit of it, to save your work. The version of KiCad I'm actually using in this video right now is actually it's a nightly build, which means you should not be using it for development purposes. However, I'm on the development team for KiCad, so I'm actually hoping that it crashes or something bad goes wrong, or something that I notice that is something that's wrong, so that we can get that working right. There's actually, as of right now, the new version of KiCad, and that's 4.0.7. That should be coming out any day now. There's still a few more problems. Not big problems, just little stuff. And we're just knocking it out. And we're playing with the designators and the values. Get everything nice and nice. Typically when I make a board, I like to have the values on the board so that it's actually in copper rather than just having the designator. Because when you're making your own board, you want to, if I can avoid from printing out another piece of paper for all the pinouts and all that stuff, I mean for which designator the values go to. I mean, if I can just look at the board because it's already been etched and that information is there right in front of me, that gets populating the board much quicker. And I like that. I like being efficient with getting things done. I like that. So there's our transistor there. Want to have that nearby something so that these are the test points for it. It's nice to have test points for transistors, any kind of major output system, anything like that, so that if you want to be able to, like, if something's not working right, you want to be able to just go right in there, do a quick measurement, see if pins are shorted out, whatever the case may be. You want to be able to do that. Definitely want to be able to do that and have quick access to it without having to scratch up the leads on the component itself. If you can just touch a pad on the board and do a quick measurement, that's the way to go. So don't be afraid of test points. You gotta put test points out there. Yeah, it takes up a little bit more real estate on your board. However, it's very helpful when you're knocking out a new design or something that you think you might be having to test later on. It's a good thing to have. And it looks like we have all our parts on the board now. And that's our output from the transistor. Let's see what we've got. Just looking at things, do a quick size check. I believe in the menu, I think I'm laying out the size for the dimensions of the thicknesses of the the traces. So I'm starting at 0.2 millimeter, and I'm going all the way up to 1 millimeter for track width. I believe that's what I'm doing now, and unfortunately, like I said, you can't see the menu, so yeah, sorry about that. But that's typically what I'm doing right there, and I'm going through the making sure everything's there. I know you can't see that. So, okay. Going through the menu here. Making sure that, let's see, what would I have been doing there? That would have been making sure that traces are, that they snap at 45-degree angles. And we're looking at the board here in 3D. Looks pretty good. Not bad. Some of the designators are not on the board. We can adjust those later. But right now, it's taking a look at the board, seeing what's there. Because it's one thing when you see it on a flat plane, you know. When you see it in 3D, you can actually see where you might have, you know, three-dimensional objects that are going to be in the way. Things that I'm looking for spacing for where I can get my iron in there. Just running through all of those motions, and it looks like we're going to start knocking out the traces now. And this is where the puzzle really comes into play, because I don't use an auto router. Sometimes on a larger board, I'll actually use an auto router just to get a feel for where the traces are going to be, where I'll have problems, and then after it's all done, I delete everything the computer did as far as the auto routing stuff, and then just start from scratch. But I do like to do the auto router just to get an idea of what where snags might be, because you can tell where the auto router is having a difficult time getting traces through, and that would be something that I would make a mental note of. But I don't think we're going to do that in this part, in this board here, because it's pretty cut and dry. It's a pretty simple board, and I think we can handle that. So I'm going to change the track width there, and I'm going to zoom in, I think. Zoom in, see what kind of, see if I got the diameter of the traces right. And we're going to go by hand with it. I like coming in at a forward angle, just to make soldering easy. I found that if I have traces coming in from under the board and I'm hand soldering, I want to be able to confirm that the trace has actually been soldered. Because if you're soldering from a trace from underneath the component, you really can't tell. So if you have the trace coming out forward, like it's you have that one extra sense of confirmation that you've soldered that component properly. That one I'm still having. That one I believe I had the most fun with. That was the most difficult part of the whole thing. Was yeah, R3. And I think I was just trying to figure out how to get that one trace over there. Because you can see how I got to go from there to there. And I widen the track there a little bit. you want to use the largest track traces that you can, and then you know, you cycle down as you have to. I kinda and don't like that. Yeah. I'm still trying to think how I want that to be. I can get pretty anal about how my traces look, even though there's nothing wrong with it. I like perfection, so that's what I strive for. So I'm gonna bring that over. Like I said, I like to come in at a forward angle so that you can tell that you've soldered the product right. See what I mean there? I'm just looking for consistency, things like that. So I'm going to move that, and I want that centered. So right here, that's not right. There we go. Yeah, it looks aesthetically pleasing, you know. I like that. Looks good. Taking a look at things and seeing what I can get. I like the right angles. I like the way it looks on a homemade board. It doesn't matter. It's personal preference. But these are really large traces. I think that's a 1mm trace. So I mean, it's large for the signals that this board is going to be handling. That's plenty large enough. And I'm adjusting the track width there again. I think that particular track width was 0.7. I believe that was 0.7. And the other size that I'm using is 1mm. So those are the two sizes that I used typically throughout the entire board. I think there was at one time I had to shrink down, but we'll get to that in a minute. And I'm still playing with that one trace there, aren't I? There's a new I forget what the I forget what it's called, but it's a new it's something that some of the guys have been working on KiCad. It's to smooth those out, you know, those round bumps there at the corner there, you see that? And it does a gradual transition. It's really nice. It works really, it comes out looking really nice. You know? But let's get those test points done. Still contemplating how to get to that other lead there. So that's what I'm thinking about there. How do I get over there? Because I know that I'm either going to need a jumper, which I don't want to have to use, I know the spacing there is pretty tight. Yeah, I'm just giving a good look here. And let's see what else we got. Clear that up. So I just flipped that component to the other side of the board because I know those parts are through hole from that type of footprint, and I'm just going to set up the contrast here. There we go. And I know I'm going to need to get to the other side of the board, which isn't a problem. This would certainly have worked. That would have most certainly have worked. I know I don't like it, so I'm just going through the motions here. Yeah, I'm pretty sure I don't like that. I'm trying to think how can I do this a better way. That solution right there would have certainly worked. It would have been just fine. That would have worked just fine. I don't know. I know I really want to do this whole thing on one side of the board. I'm pretty sure. Yeah, we're going to look at this in 3D soon, I think. Yeah, I don't think I like it. So, yeah, we're going to bring that back over. And that's kind of, I think, and that's pretty much the technique that I use there. And I know that that's pretty close. Pretty close. So we're going to focus on this part right here for a little while. I'm still sitting there thinking how I want to do that. And what I think we'll do is, yeah, I'm just seeing where parts need to go. How do I get over there? And I know I'm looking at it, and I know I don't like that, because I don't like it right now. And I know I'm working on something else. I moved on a little bit, I guess, just to get away from it, you know. And that didn't take very long, did it? So. Playing around. Yeah, I'm still not happy with that. I think, yeah, the LT 1716, I think I'm going to slide that over a little bit. Just start deleting traces here and reposition that comparator. Pretty sure I don't like that. Yeah, I was contemplating all kinds of things. How do I do that? How do I get over there? And we're going to start getting rid of traces now. There we go. We're just going to get rid of all that crap. And we're going to redo it. Yep, so we're going to rip that component up. Probably move it over to the left there. And just to give us some more room for what I want to do, because I know I don't want to move the that potentiometer, because I wanted to keep that dead center of the board. And I'm pretty sure we can get all this done. And you remember what I said about having the those leads coming out in a from the forward view on the leads on the SMD packages. So I'm trying to squeeze enough room in there to make all that work. I'm determining whether I should change the footprint for R3. I don't know if I want to do that yet, but it certainly has crossed my mind, because I'm thinking about doing that now, so I've certainly thought about it then. And like I said, we're just going to rip up the board a little bit and get some of this stuff lined up. Just thinking things through. Centered. I'm looking for alignment. I'm going to make that trace a little thinner. Yep. Just to give us some buffer space, you know. And go back to 0.7 millimeter. I believe that was the solution we picked to do. I know that looks ugly, so I want to try to clean that up a little bit, but know I'm looking at it and I'm like, man, I don't like it. But I think I'm just going to keep moving on a little bit. You know, sometimes you just want to get away from it. And just continue to get something done. You know, but at the same time, you're keeping it in your mind's eye. You know, and you're in the back of your mind how you're going to get everything all lined up. thinking how I want to go through all this. Just going through the motions. It's kind of fun to watch this. I mean, it is for me anyway. I mean, I could watch this kind of stuff all day. I find this to be almost therapeutic. It's just because I love it so much that I just can't help it. And so it looks like we're going to do a save here. Oh, I'm doing what I'm doing now is I'm setting up the fill grid. I'm setting up the diameters for the fill, for the grid, for the ground fill, for the ground plane. That's what I'm making there. Make sure everything lines up. And there we go. Save it. Do a DRC check. That's the design rule check. And there's our ground plane. And now what I'm going to do is make sure that there are. Oh, we got one unconnected there. As you can see, I pointed out. I see two of them. I don't know what it says. Oh, 5. Sorry. We got 5 connections to ground that we can't get to. Okay, that trace has got to get moved. And do another design rule check. And that didn't do it. So I'm going to loosen up on the spacing for the fill, which I would be doing now. And keep trying, and that didn't work. So I'm thinking, okay, can I do that again? And I'm going into the zone there to readjust some of the fill settings. And what that would do is that would give me the clearance space, and that wasn't close enough. I'm really sorry. That would have been a really valuable thing for you to be able to see the settings that I did or chose to do. And now we're down to 3 connections now. Yeah, those 2 traces down at the top and the bottom of the board there kind of giving me a hard time. So I'm going to loosen up on the clearance constraints. And that's what I would be doing here. So I'm tired. I know, let's see, I think I changed the segment spacings from 16 to 32 so that it's a nicer transition. And there we go. We got our trace going at the top and at the bottom. Do another design rule check. And we have 1 disconnected. What's going on? How did that happen? Oh, okay. There's a solution to that, isn't there? There we go. We might lower the track width there. There we go. And we're done. What do you think? It's not bad. Let's do another design rule check. Verify that everything's there. Yep. 0 unconnected. 47 connections. 69 pads total. And I'm doing an extensive test on clearances and stuff. And unfortunately, we can't even see the dialog box, so I can't remember what the errors were. I was doing that just to verify that the software was going to give me exactly the results that I wanted it to. Because, like I said, this is a nightly build of this version, which is something you don't want to use if you're going into production. So here's the 3D model after all the traces are on there. And take a look. Everything's on one side of the board. That's kind of the holy grail of doing traces on a board. Just to get everything on one side of the board without any jumpers or anything. So that's kind of elegant. I like that. And yeah, I'm really concentrating on that part right there. I'm looking to see what kind of clearance spaces we're going to have, and I'm just getting all the angles. And you couldn't possibly do this if you were just using a two-dimensional plane here. So 3D really does come into play at times like that, where you really want to see how things are going to look. Can you get your iron in there? Can you solder every component without anything getting too mixed up and getting that in your way, And just look at every angle. I'm pretty sure I'm liking it. Yeah, I'm just concentrating on that one major part there. Yeah, looks good. There we go. I think what I'm going to do now is delete that and relocate the circuit board to the center of the board, or to the center of the paper. Give or take the center, it's close enough. Might even make sure that the paper is the correct size, because I believe it defaults to A4 type, the A4 size. And I want to make sure that when I print it out, it is to scale. So I have to make sure that I pick 8.5 by 11. That's the U.S. letter size. And boy, I can't tell you how many times I've, printed out something and ironed it onto a board, or did a and then when you get to the other side of the board, if it's a two-sided board, you go and find out that hey, it's too small for this board and these footprints don't fit. So yeah, you want to make sure you're using the right size board. And it looks like I'm showing you how to do how to export the files properly, so that edge cuts is the sides of the board, and I'm making sure the pads are plotted. I like having the values of the components on the board, so that would be considered an invisible value. Drill marks, I want actual size, and we're going to plot it. And we're done. Let's see. And you want to mirror your plot if you're going to use a toner transfer.